We have some new details that came out about the OpenAI-HuggingFace attack, some timelines, and some CVEs that ultimately left me with more questions than answers. Now, if you're not sure what I'm talking about, last week on the 21st, OpenAI disclosed that they, the company, accidentally hacked another company. Accidentally is in quotes. There's some questions that I have about that. But basically what occurred, right, is OpenAI, while trying to evaluate its frontier new model on cyber benchmarks, right, the ability to find and exploit vulnerabilities, it escaped the cage, right, the sandbox that they put it in, and it eventually went and hacked HuggingFace in an attempt to find the answers to this benchmark, right, this benchmark being exploit bench that they're able to use to figure out how good are you at exploiting vulnerabilities. Now, when this first came out, there were almost no details, right? We knew nothing except for the fact that HuggingFace disclosed a new kind of security incident over the weekend, and then that Tuesday, this report from OpenAI came out saying, hey guys, that hack you saw was us, our bad. And the world was kind of just waiting for more detail to come out, right? Because there were claims in this article that one, the OpenAI model found a vulnerability in a proxy software and exploited that to escape its sandbox into the internet. And then two, it exploited other zero-day vulnerabilities in HuggingFace and completely owned their infrastructure to get access to the exploit bench models. Like insane stuff. Now, the first question that everyone had, right, was like, how the hell did the model in quotes, it's not really the model, it's like the actions the model are taking, how did those escape OpenAI infrastructure, right? How did it escape the sandbox? A lot of the questions that cyber practitioners had is, how are OpenAI, the security team there, not doing like the basic network monitoring and network firewalling to prevent the machine that has the OpenAI model on it from leaving the network? Guys, I know we talk a lot on this channel about people finding vulnerabilities using AI, but unfortunately, threat actors are also using AI to be a lot faster in their campaigns. And that's why today's video is sponsored by Flare. Flare is a threat intelligence platform that allows you to see inside the world of cybercrime, to see exactly what hackers are doing and if your credentials are compromised by their campaigns. And with over 2 billion events collected in the last 3 months, Flare has collectors all over the place to let you know exactly what is going on in the world of cybercrime. And here we have an example of one of the things that Flare Cyber Threat Intel does pick up. There's a new kind of campaign going on where threat actors are using AI to automate phishing campaigns, right? And when they collect the phished credentials, they actually use a Telegram channel as kind of their C2, right? They post the credentials to the C2 channel in Telegram, and they have people that are actively picking up this data and reporting it to Flare. And Flare has a way to actively pick up this data and put it into the system. There's some data here that's redacted, but what you get is a feed of the emails, passwords, and IP addresses that are compromised in these campaigns. So if you have these identifiers set up in the Flare system, the minute it's collected by Flare, you get a notification of what got collected, where it came from, and where remediation needs to start. As we know that bugs are going to happen, we know that exploits are going to occur, we know that compromises will eventually take part in our network. Now, the best way to stay ahead of them is to know exactly when the compromise occurs by tracking our credentials with threat intelligence. Go check out Flare at the link right here. Flare, thank you for sponsoring the video. Let's get back to it. Well, this is how it went down. According to the reports that we're reading, again, we don't know a lot of the detail exactly how it happened, but we can kind of put some pieces together, right? So in any corporate environment, you have this piece of software called Artifactory by a company called JFrog. And Artifactory is used, as the name kind of implies, to store artifacts, right? An artifact can be anything that is used either during or after the software development process, right? So if you want to put your releases of your software in Artifactory, that is the way that you can use it. If you want to store your packages, like a package proxy in Artifactory, you can do that as well. And so in the infrastructure of OpenAI, when they were doing this test, they were using Artifactory as a way to store packages for like Python and Java and all this and Go, for example, inside of Artifactory. Now, this next part is speculation, but I'm pretty sure this is like how it's set up. Likely the way this worked is they had this OpenAI box inside of a network somewhere, and the box was not allowed to leave the internet, right? They had maybe some like network IP address rule that said like, hey, 192.168.0.2 or whatever, some host name is not allowed to go outside of the perimeter firewall for the network, which is like a good way, a decent way of making sure that the model does not escape the sandbox, right? Does not leave to the internet while still having some kind of way for them to get Python packages or Go packages when they're doing their exploit development, right? And so the AI, again, the reason why the AI went and hacked HuggingFace in the first place, I still don't fully understand. But either way, OpenAI's model decided this exploit bench is too hard. Let's go find the models on HuggingFace. And so step one was, let's figure out how to leave the sandbox and escape and hit the internet. Now, the model deduced that because JFrog, the package repo, the package proxy, had internet access, supposedly, it had had to find a vulnerability in JFrog. And so yesterday, JFrog put out a patch that addresses, I believe, 9 CVEs, okay? Now, there is no indication as to which CVEs were exploited in the actual attack, right? They haven't disclosed any of that. But if you read the vulnerabilities that are disclosed, and then you read what Hugging Face and OpenAI say happened during the attack, OpenAI is saying that Hugging Face used the proxy to get out to the internet. It maintains some kind of persistence on the proxy, which therefore implies it needs to have remote code execution on the proxy. If you read some of these vulnerabilities, you can kind of deduce what happened, right? So the 2 ones that could give RCE are designed to prevent an unsafe GEMS package deserialization that could lead to remote code execution. So the idea here being, if you proxy a package that is designed in a way that exploits this vulnerability, you can use that package as it goes through the proxy, supposedly, I'm kind of guessing here, to get RCE on the midpoint, okay? And now the question that I have is, like, if they weren't able to access the internet, how did they get a GEMS package that was set up the right way to be able to do this, right? There's a bunch of other vulnerabilities. The 2 that kind of caught my eye as well were server-side request forgery via the Terraform, and I believe it was Ansible provider URLs. So maybe they did some kind of SSRF to like forge a repo somewhere else, and they pulled it through using GEMS. The main question I have here is, like, JFrog Artifactory is a closed source software, so there has to be, like, I'm not really sure how the model went through and found these bugs. But that being said, it exploited these vulnerabilities to get some kind of persistence on this device, right? On this piece of middleware that was the gateway between it and the internet. Now, this image here is actually an image from Hugging Face that kind of lays out how they believe the attack went down, right? I think a lot of the left side of this is kind of a guess on their part, but everything here in the Hugging Face perimeter is like them literally like reading their logs and figuring out what occurred. One thing that like the news is kind of glossing over is like OpenAI didn't hack one website. Like, yeah, they hacked into Hugging Face and like stole the answers to exploit bench as the model wanted to, but they actually used a different website entirely. By the way, a sandbox website. They exploited a sandbox website and used that as their C2, their command and control for the rest of this operation, right? So I think the model somehow knew, and again, I'm not like anthropomorphizing the model. I'm not saying like it knew like it's a person. I'm saying, you know, the model as the model is intended figured out that something about the proxy was either ephemeral or like this, that it wasn't going to last very long. And so it figured out how to maintain C2 on this sandbox environment, right? Which is pretty cool. And then from there, it went and exploited 2 separate vulnerabilities in Hugging Face. And Hugging Face actually was very nice and like disclosed kind of the full details of to get the access that it needed. Again, the end goal here was that it went through and compromised almost the totality of Hugging Face architecture. Now, I don't know a ton about Hugging Face, but what I'm reading from here is that you can upload data sets to Hugging Face. And when you do this, you specify some kind of config file, right? And inside the config file, there are subconfigs for different config names for that data. Well, what's interesting is they were actually able to use these config names, and the config name itself is associated to some file path, right? Well, if you're not like a Linux guru, right, there's this whole thing called the proc file system. You can do proc self something. And if you are able to open files in the context of a process, but you don't want people to see secrets in like the environment, if you don't jail them to not be able to read the procfs, they can read things like proc self environ, which is just a file that points to the environment of the current running process, right? And so you can use this to enumerate things just like they did, like local environment secrets and credentials that are being ran in the scope of the container that this is being ran on. And this is all being done inside of some kind of Kubernetes pod, right? And so they use this config vulnerability to exfiltrate secrets and tokens, and then from there, use that to exploit a separate vulnerability, which is a Jinja template injection. So, you know, Jinja is one of those template libraries in Python, and like any good template library, right, there are plenty of ways, if it's not properly configured, to be able to run code. So they have this import gzip, import basics. They put some payload in here that got base64 decoded, that got gzip decompressed, and then they ran that as Python, right? So they use that to run this Python arbitrarily in the worker pod on their Kubernetes cluster, driven by injection for the launchpad, right? So they're using all of this to eventually get deep inside the infrastructure of Hugging Face. Now, again, I don't know a ton about Hugging Face architecture. I don't know exactly what was stolen, but you can see here, right? They have literally the whole timeline, which was actually a Thursday, interesting, down to the 11th, where it was doing all of this stealing of data via direct command injection. It's doing this obfuscation via base64 and gzip blobs, ultimately stealing the data and exfiltrating it outside of the network. insane. Now, the question that I have, you can reference my production grade penetration testing report card here, right? So we have these two instances inside the OpenAI infrastructure. I'll put OpenAI here so we don't get confused. We have the computer that is running the model and it's touching one of the local GPUs or whatever. And then, it's using this exploit to go to JFrog. And so the original question that I had is how the hell is it possible that the model was not sandboxed in a way that it couldn't leave the network? And so what could be occurring is there's some network level rule that says 192.168.0.1 is bad and 192.168.0.2 is good. And so the model could detect that through some kind of like network package or network inspection by seeing what packets get dropped. And it said, okay, cool, we got to find that endpoint to get through the network. And eventually they break out via hacking this thing. Okay, so this is a way that you could escape. This is very common hacker stuff. But here's a question for the class that I have. Have you ever used one of these tools? Have you ever used Codex or Claude CLI? I just realized when I was like pulling this up to show you guys, Claude recently added it's weird, sandbox.network.strict allow list. I wonder why they would add that at such an interesting time in the world's news. Anyway, guys, when you're using these models, if you go to the screen where the model is doing something, it will literally tell you what it is thinking. And so the fact that this is able to run for 2 days and no one went to the model and like saw it being like literally pwning all of HuggingFace, like deep as fuck inside of HuggingFace's network, extracting all the files. No one was like, whoa, what the fuck is that? What is happening? What? That to me is concerning. And again, I'm not trying to throw shade at anybody at any company. It's just like, we're talking about how dangerous these models are. And what is even more dangerous than these models is like just negligence on the thing you're doing, where you take supposedly like your cyber nuclear bomb model, run it with no safeguards in a network environment that like isn't air gapped. And you're just like, yep, that was definitely the model's fault and not ours for not watching it for 4 days. On the topic of like model danger, by the way, there's this whole conversation in the industry right now about like, should open source models be banned because they're Chinese and evil? And like the funny part is Hugging Face, in trying to respond to and like figure out what happened during this incident, they tried to dump some of their logs, like the attack commands, exploit payloads, C2 artifacts, etc., into the frontier models. I'm assuming both Anthropic's and OpenAI's. And because Hugging Face was not a member of like the top secret like cyber society that these companies have, they weren't able to. They literally got denied access by the models. So they instead had to go and use GLM 5.2, an open weight model on their own infrastructure in order to be able to do defensive actions. This is literally, and I've said this like a few times in like different videos and shit, but this is like the Harry Potter like defense against the dark arts with like the Ministry of Magic thing. Like you had like the teacher be like, oh, you should learn those spells because they're evil. But like, yeah, dude, you have to know how those spells work or be able to like use those spells to know how to defend against them. And this is like the same argument we had in like the early 2000s with like Metasploit, right? The idea with Metasploit being, oh, Metasploit democratizes exploitation and makes everyone too dangerous. And it's like, yeah, and by teaching defenders how to do offense, we therefore make better defenders. And the same thing applies here to like the AI world, right? If we don't give everyone the ability to do offense, if we don't democratize exploitation, we're also not democratizing defense, which is a huge problem. Anyway, that's my little rant. Longer video than usual. This incident is so interesting to me. I'm not trying to shoot shit or talk bad on anybody. I just find it very annoying that like world's biggest AI does really bad thing. And it's like, well, no, you guys just weren't watching it do its job. Kind of weird. Okay, bye.